Hey, physics, or not physics, math 30-1s. We're going to do worksheet number 3 here. We're going to use combination this time. Combinations, practice questions, maybe? I don't know. Maybe I missed an S there. That's fine. On these ones here, we're going to solve for n. I'm going to try to do these algebraically up to a certain point. If it gets too complex with a cubic or a quartic function, I'm just going to ignore it and just solve by graphing it at that point. Right? I can't really graph NC2 and expect this to work very well. You can put it in your graph and then you go to your table. It won't show necessarily a graph. It'll be a bunch of dots because you won't be able to connect the dots between the two. But what I'm going to do is I'm just going to set up my formula here. So I know NC2 is going to say NCR is going to be N over N minus R, which is going to be N minus 2 factorial. And then R factorial, which is going to be 2 factorial. Okay. So that's how that's going to be set up. So I'm just going to quickly rearrange this, do some simplifying here. So this 2 factorial is going to multiply up to the other side. It's going to be n factorial. N minus 2 factorial is equal to 30. Okay. Then what I'm going to do is I'm going to expand out that n factorial to n times n minus 1 factorial, but that doesn't cancel out, so I'll keep on going. Oh, and then stop at 2 factorial. So n minus 2 factorial. That's going to reduce out. It's going to be equal to 30. And then at the same time, I'm going to multiply that up because it's going to end up being a quadratic. That's fine. And can't really scroll up here, so I'm just going to move my face down. And I'm going to make this equal to 0 because it's a nice little quadratic. So it's going to be n squared minus n minus 30. And then I'm going to factor this. This is a quadratic, so I should be able to factor this pretty easily. We've got 6 and 5. We got negative 6, positive 5. So n is equal to 6 and negative 5. And then you cross off the negatives because that doesn't make sense. Right? And then you just verify. I'm just going to put in my calculator here. N math for the C. And then put a 2 there. Yeah, I get 15. 6C2 is 15. So that does work out. So we can do this algebraically. Let's see if we can do this one algebraically. I'm going to give myself a little bit more space here. Make all those little squiggles and it just straightens it right out. Okay, so we're going to have n factorial on the top. So that's going to be n minus 1 factorial because the n is this whole side and the r is the other side here. Then we're going to have n minus r. So it's going to be n plus 1 minus n minus 1 factorial. And then I have n minus 1 factorial. And then I have 15 on this side. Because I know that, okay, based on what the math up here, 6 and 2 are going to work. Like, so 6 and 2, what would make 6 and 2 here? Or some other numbers might work too. I don't think 6 and 2 would give us a, yeah, they're not far enough apart. So n minus n is 0, 1 minus negative 1, so that's 2. So this ends up being, this simplifies down to n plus 1 factorial, 2 factorial, n minus 1 factorial, 15. Okay? Then what I'm going to do, I'm going to times, just like here, I'm going to times the 2 factorial up to the other side. And then I'm going to start expanding out the larger factorial. I'm just going to try to do this as one step. So I expanded the larger one. The n plus 1 is larger than n minus 1. So I'm going to expand this out. 1 less than this is going to be n. 1 less than this one is going to be n minus 1 factorial. That's good. That's what we want here. That cancels out. That's equal to 30. Now, I'm going to multiply the n in. So I get n squared plus n is equal to 30. N squared plus n minus 30 is equal to 0. And I'm going to factor this. So if I factor this, I'm going to get n plus 6 this time, and n minus 5 is equal to 0. Let's move my head to the top now. So n is either negative 6 or positive 5. You cross off the 6 here, so n is equal to 5. So what would that be? 6C3. All right. Oh, 6C4. Yeah, 6C4 should work. If 6C2 works, 6C4 should also work because the 2 and the 4 add together. So it just kind of makes sense, kind of like what we had here. I had 6 books. I choose 2 of them. That's the same as, if there's a, say that, it'd be the same as choosing 4 of them. It'd be the same. Just like in the statement down here, showing that these are the same. If I have 10 books, is that the same as choosing 3 or choosing 7? So you got to think of, if I choose 3, I'm technically leaving 7 behind. So I've just chosen those 7 as well. Okay? So I want to show mathematically that these are true to each other, right? So I could just plug in my calculator. Okay, that's fine. It works out the same way, but I'm going to just show this using algebra. So we got 10 factorial. That's going to be n factorial. Then you got n, so 10 minus 3 factorial, and then 3 factorial. Okay. On this side, we got 10 factorial, and then I'm going to have 10 minus 7 factorial, 7 factorial. Okay, you got some slightly different numbers, but if I simplify these down, 7 factorial, 3 factorial, then 10 factorial is 3 factorial, 7 factorial. Okay, those are the same thing, right? They just end up in the left side, ends up being the right side in this situation. So at least it verifies that it works there. Yeah, I'm not going to bother simplifying that down anymore. Okay, so this one here, these ones here are very similar to the one above it. I want these to be the same. In this case, we're just looking for the n value that would make these the same. Like I would know these would be the same if both of these were 5 on this side, but they both can't be 5 in this situation. So I'm going to set up the formula and then start simplifying things down. So I'm going to have n plus 2 factorial. And then on this one here, I'm going to have n plus 2 minus 3, because this is the n minus r, factorial, 3 factorial. And on the other side, I'm going to have an n plus 1 factorial. And this is going to be n plus 1 minus 2 factorial, 2 factorial. Cool. Let's simplify this down just a little bit here. N plus 2 factorial. 2 minus 3, that's n minus 1 factorial, 3 factorial. And then on this side, I'm going to have n plus 1 factorial. And then 1 minus 2, that's also n minus 1 factorial, 2 factorial. Okay, so since both of these are in the denominator, I can multiply them up to either side and they reduce out. What I'm going to do with the numbers here, well, I'll just leave the numbers. So I can calculate them. So 3 factorial is 6. 2 factorial is 2. Or 4, sorry. No, it's 2. Where was it picking? It's 2. Okay. I'll leave this. Okay. I'm going to show most of my steps here. Cool. Now what I'm going to do, I'm allowed to move between the equal sign because I'm not proving this. I'm just want to verify this, or solve in this case, what n value would be. So by multiplying over it, I can get rid of those pieces. You're going to now start simplifying the biggest piece like we did in the first question there. So n plus 2 is bigger than n plus 1. So I'm going to start expanding that out. So 1 less than n plus 2 is n plus 1. So I'm going to stop there because on the other side, we have an n plus 1 as well. So those are going to reduce out. Perfect. I'm going to run out of space on this page. Let's go up here. Okay. Then I have n plus 2 over 6 is equal to 1 over 2. I'm going to times that up to 3, because it'd be 6 divided by 2, minus that over again, 1. So n is equal to 1. Cool. Pretty cool. Okay. So we're going to do the same thing with this one. This one has, seems like nicer numbers. But we'll see. So n plus 1 factorial n factorial, and this is going to be on the bottom here, is going to be n minus 4 factorial, 4 factorial. That's a nice one. This one's going to be a bit trickier. It's going to be n minus 1 minus 5. 1 minus 5 is n minus 4. That worked out nicely too. Cool, cool. Rather than finding what 4 factorial and 5 factorial are, I'm going to multiply up. So yeah, okay, let me just do a few things here. I'm going to get rid of these. And I'm going to multiply up the 5 factorial to the other side. Okay, and then we have this. I'm going to expand out the bigger one. N plus 1, n factorial times 5. 5 factorial divided by 4 factorial is 5. I'm not going to show the work on that, but you can do it. And then you're going to reduce out the n factorials. Nice. And we're going to get n plus 1 is equal to 5. N is equal to 4. Perfect. Well, it makes sense. 5C5 is equal to 4C4. Yeah, it makes sense. The last little question here is just to determine which of these is the permutation, which one would be a combination time question. We don't have to actually solve the questions. So a coin is tossed 9 times. How many ways could the result be 6 heads followed by 3 tails? Because the order matters there, because it has to be followed by. This would be definitely a permutation because it's followed by. Now, if it just said 6 heads and 6 tails, I'm not too concerned about that. So that would be a combination if it was just that. But because of the word followed by, it's going to be a permutation. Order matters there. How many ways can 3 coins be selected from 9? Yeah, so I'm thinking that you just grab the coins, they're in your hand. You're just looking at the coins in your hand. If you said if you were arranging the 3 coins from the 9 on the table here, then that would be permutations. But because they don't mention anything about arranging, I'm going to say that this is combinations. A combination. A ski team has 12 members. How many be selected to compete in the finals? Okay, I would say this is a combination because they're competing. Now, how many ways can they be arranged on the podium at the end? That would be a permutation. Like if there was 5 positions or 5 placements. How many? Well, I'm just going to say briefly describe why. I'm just going to say see video. If you want to. Okay, if you want to know why. How many numbers are less than 400 can be made from this? Because the numbers, the order matters. This is definitely a permutation question. If we did those questions in the permutation section there. Cool. There we go. And I'll see you in the next video. Bye.